Whoa. Alright, let's see. Anybody here? Hey, hello, Nico. No, I just couldn't get my stuff together yesterday. And I ended up rescheduling it. So I had all... yes, I was planning a regular stream at the regular time, at the normal time between half past and the top of the hour, but I just couldn't. Things just kept happening yesterday. So, and it took me, and then I completely forgot, and then I forgot to, and I thought about it. I was like, I needed to come and change the schedule and let everybody know, or even make a comment. But just like I said, I couldn't get things together yesterday. So I think about 3 or 4 hours late, I think I ended up rescheduling it. And I think I had 3 or 4 people waiting. I can't remember. But all right. And so today's stream we're going to look at, we're probably going to record, I need to at least record one today, because I want to try to get back into where I need to at least publish a regular video at least 3 times a week. I don't think I can do 4. Learned how to make. Okay, that's pretty cool. Like a physical, negative, and then a photo. That's pretty impressive. I have no idea where to even start with that. So all right, in today's, I saw this and I liked this because I was actually thinking about. There was it's not encryption, but it's basically like a cipher. Yeah, a cipher where you shifted. So this is going to be very similar to that cipher. So let's see. Given a string column title that represents the column title as appears in an Excel sheet, return the corresponding column number. So, of course, a picture is worth 1,000 words. So the first column is A, the second column is B, the third column is C, and so on. The numbers of the alphabet. Now, and I didn't deal with anything large enough in my personal life until I started working at my last job, and then I was seeing double. I was like, wait a minute, wait, what? There was one. There was max exposure. Oh yes. For a time, my wife was a photographer, and she took photos, and she taught me a lot about, or I tried to learn a lot about exposure time. She has a photo of one of our downtown areas, and she had the exposure kept open, and you can see the lights. It's like streams of lights, and it just all merges together instead of a headlight moving down the road. Just kind of streams it together. It's one of my favorite photos that she's taken. So all right, back to today's puzzle. So if you're of course given A, the output would be 1, and if you're given AB, the output would be 28. Holy moly. And of course then you're given ZY, it is the 701st column. So I haven't thought about this at all, and we're probably going to talk, because I know I do want to talk about over-engineering for a second. I don't know if anyone here is even old enough to know what a Rube Goldberg machine is. It was utilized a lot, like in the 80s, for silliness, where you'd have a contraption where it would do all sorts of mechanical operations to do typically a very simple task. So just a little visual of thinking about over-engineering and making sure, because I don't know if that's going to be the video, but these are the 3 that I do want to record today. And I kind of maybe want to make a series on junior versus senior, get it done, and then a very elegant, optimized way. and kind of like my first attempt, and then I think that and then completely optimized, and then focusing on this is a title that I came up with, understanding the anatomy of your objects. I don't know, that just sounds interesting to me and just something I want to talk about. So all right, do you like yes, I do. It was very elegant. I like that a lot. Okay. I thought it was very clever. All right. So where do we need to start with this? So I guess first we need to get this. Let's get the single characters to work. So if it's A, it's B, it's B, it's A, it's ooh, wait a second. All right, so what came to mind is a dictionary. So let's see. Does everybody know the strings? String or strings? String. The string module. It's very handy. So this is what I saw, that it worked with Dot Notate Edition too. I was very impressed with that. So all right. So string is a module that's already in Python, and we can look at probably, if we look right here so we don't have to convert anything, let's do ASCII uppercase. So string ASCII. Venki, how are you? Good day to you. Give me a second to type this right so I don't, is it that? Yeah, bingo. All right. So what we're doing is it's Leetcode 171, and here's the example output. So it's going to be very similar to a cipher, a shifted or a sort cipher, and I love these a lot. I need to find one of those. So we're going to work on this, and I would love to do all 3 videos today so we can get them done and out of the way, and we could just edit later. But I at least need to record one of these today so I can publish it when we get done. And I just realized I didn't do something that I needed to right before, but it'll be all right. So it's a shuffle concept in my head, and Venki may already have a solution. I didn't know that about that. It highlighted everything. Let's see if we can do it again. Nope. All right. So if we get a string A, the output is 1. We get AB. It's column number 26. So it corresponds, and it is exactly like numbering the Excel spreadsheet, the column numbers. So if we were given ZY, what's the column number? What number column is it? All right. Well, I think that's neat, Nico. Why don't you get started on that and see how it goes? I think that's a great idea. Anything where you're creating something and it's challenging to you, I highly encourage you, because you're gonna learn something from it. You're gonna get something out of it, and that's the whole point of this journey. So, I was doing some research on data engineering, and it dawned on me that the first part of my job, I had no idea when I first got the last job, my previous job, that how much of the data engineering practices was taking raw scan data. I didn't understand how big of a deal it was. So I now have to try to explain what I was doing with taking these post JSON objects that were just raw scan data, just unbelievable amounts of raw scan data, and then I was transforming it and the algorithm that I was doing, and we were loading it back into a very clean table to decide if it was going to get charges or not. Okay, all the making AI or like static AIs, all this stuff aren't useful at all, right? Except the cancer detector. Yeah, true. So yeah. I mean, the whole point of well, we all know nothing before we get started. So that don't be afraid of not knowing something, because everything was unknown until it was known. I mean, and I've been wrapping my head around. I've been reading 2 books on the atomic bomb. One is basically the social interaction of it, basically the book that the Oppenheimer movie is based upon, and the other one is one my daughter got me that covers basically the entire history of physical chemistry, thermodynamics, and the physics that invented the atom bomb. Particle theory, just and going all the way back to Europe, where it's eluding me of but every little step, the discovery of decay, alpha particles, beta particles, energy, and just were mystified of how all it worked. So everything is unknown until it's known. So you just have to get in there and clunk around with it, because look, I don't know how to do this right now, but my human brain, so it's a conversion of human brain decision to writing a program that can do this for us. All right. When I see a new person learning, it makes me a bit more. Yeah, I get it. Actually, that's one of the things, the reason why I'm kind of re-obsessed with learning and figuring new things out is when I started jiu-jitsu about a year and a couple months ago, is I'd heard all the older guys, and I thought it was just a line trying to make me feel better. Oh, I know it's going to feel like you're not learning anything until you keep going and the new guys keep coming in, and then you go with a new guy. It's gonna be night and day. And I was like, yeah, you're just being nice. But it is the case. The further point you are from the start, and when you're in it, you're in your bubble. You're in the fog of war, whatever term you want to use. You can't see the forest through the trees, blah, 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 blah. All these things are saying is that if you're looking, actually it's in the theory of relativity. If I was just seeing about this earlier, and what it is if you're on a constantly moving object, there's no experiment to be able to do to figure that out, because everything is static. And I still don't completely understand it, but I kept reading it over and over and over again. It's the basis for Albert Einstein's theory of relativity, is that since we're on a constant plane, we think we're stationary, but we know we're not, or we feel stationary, but we know we're not. That's what I wanted to say. So, all right. So when you're comparing yourself to a static location, what did I learn today? Well, I can't really compare today to today, but then I can go backwards and compare myself to a year ago. Oh, I made a comment and somebody said, why don't you delete code? Here's a perfect example. You can see your progress. You can go back and look and see what garbage did I used to write, and you're like, okay, I am getting better. I think I showed several pieces of code of like my first prime number, or the first function I wrote to find a prime number. Oh my goodness, was that it was embarrassing. It was absolutely embarrassing. Excuse me. It was some of the worst logical thinking. And I think I did one. It was during my ugliness that Vinky showed. Yeah. I think I had it in like 15 lines. And now I can just spit out this right here to find if a number is prime. And I mean, if you want to count the header, 1, 2, 3, 4, 5. I say that's 4 because I mean, no matter what you do, you're gonna have to have this one. But I had a list. I was looping through everything. I was putting it in there, and then once I got done, then if it was more than 2, blah 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 blah, just garbage. But having that as a point of reference and being able to go back and look at it, it is important to your journey. So, all right, I have rambled for way too long. We're already 17 minutes in, so let's actually get going. I used to not know to use classes correctly. Yeah, classes are very important. Working code equals a win is a win. Exactly. And Dema, it's very nice to have you here. I don't believe I've seen you before, so welcome and thank you for joining us. If you've not subscribed or joined the Discord, please do that. You can get a hold of someone if you are stuck on something. So, all right, hang on. Okay, just trying to figure out what a sound was. I think it was the washer. All right. So I'm thinking we quickly make a dictionary here, right? Do we want to do a dictionary? All right. And then a list range 1 through 27. That sound good to everyone? So where I'm going with this is we iterate through the string. Ooh. All right, so we iterate through the string. So at first I was like, all right, but if this is Z, uh, 26 times 26, and then Y is what? X, Y, Z plus 25. Okay. All right. Let me show you what I just did right there. So I already know what Leetcode's going to do. So I have a tendency to not do what I say we should do because my brain lies to me a lot. Let's do this. And it's like, no, I want to do something else. And also I'll remember. Those are the two biggest lies. So we need to figure out. So basically if this is... Oh, good Lord. Because I know we're going to get a ZZA. So what I did is, so since this is the first letter, so A means we went all the way through A. And then we're going to add a B. Well, if this is ZZ, that means it went 26. So this A is 26 times 1. So it's basically... now we're heading outside of my math, but I think instead of, so our number system is a base 10. This is going to be a base 26, I think. So it's basically the equivalent of this. It's the combination. It's the combination of each position has... But that's not true. This is something completely different. All right, we need to get our dictionary made first. Before I can type this out, what do I want to do? I want to zip. Did I make? Well, first, let's get letters. Letters equals string dot ASCII uppercase letters, bingo, and then num equals what I do, list arrange 1 through 27, num, perfect. Alright, let's see if I can remember. What do we want first? We want letters and num. Bingo, that's what I wanted. Alright, everybody know how to do that? Everybody get the context that I did there. Let's rebuild everything. Alright, letters. Num. So I'll go over that real slow. Oh, import string. Okay. Equals. So what I did is I took, and it is the order key value. So D is now bingo and bingo. All right. So has everybody seen this, or at least understand what I would have done? I would have taken the letters, numbers, put it into a zip object. This is the way that I prefer to do this because it's just easier for me to visualize. So all right. So if I'm given a, let's do our normal. One, two, and three. Let's scroll this up. Yeah, I need to record those today. All right. Okay. I'll comment these two because we just want to get these. We're going to start small. I'm really going to start small today. I swear to God. All right. So if D print, this is just throwing stuff against the wall. Print D column. Is this going to work? Because first, this is already not going to work. I know it's not going to work because if we get a double, 1. All right. So cool. That works. But we also need to break this up. Holy moly. So A and B, what's going to happen with A and B? Because if it's here, we just call it. If it's in the second place, we're going to multiply it by itself, its key. Going to multiply its key. All right. So since it's A, so it's AB. Let's undo this one. Now this is going to throw up because it's like, hey, this isn't in there. So that the design that I see here is, since this is 2, but we need to make this dynamic. If this is 2, multiply this by A by 26. So A is 1 times 26 plus B. Does that make sense? So here's the design that I have. If it's length of 2, so dA times 26, because it's gone all the way through, then plus B. And then we get our 28. Now, this right here, because what would it be if it was AA? AAB. That's where it would get weird. So we've got to come up with a design to be able to understand the length of it and to iterate through. Venki, if you're still here, do you have any thoughts? Because my brain just kind of went gooey for a minute because I wanted to go forward to count how many letters. But then if we go backwards, this will be here. Then we can find out that that will be a tens place, because it's basically, the tens place is this. Well, that's a lie. That's the hundreds place, because there's 10. You got tens, tens. So I didn't want to do that. I hate it when Spider's like, oh, but you dragged it. I know what you want to do. No, you don't. Stop moving stuff. All right. Let's see. Base. I know there's probably a way to do this with base numbering, but my math is not that fancy. All right. So we need to design this algorithm to be dynamic for it to understand. Okay. Let's do something here. Column number. Boom. Enumerate for now. Okay. I don't see that. Ooh. Ooh, 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 ooh. I think I know where you're going to go with that. You try that. I'm going to do a split, and I'm going to see if we can go from there. But I do like the enumerate idea. Counter, what? Column title A. What happens if we do a split on... Oh, comment that out. Yeah. Okay. Has to be a white space or a delimiter. So we're going to have to iterate through this. So the problem with iterating through this is we won't know what place it's in as we go through it the first time. Nico, how's my color? Not great. The sun changed again on me. I tweaked the lighting, and I was prepared for the brighter lighting today, and now it's dull, and it's not the way that I was expecting it to be today. So, all right, okay. To enumerate, we're going to go through. I think your way is going to be fantastic. So, all right. Because then we would also know what position it was in. So, all right. Everybody, let's try to verbalize. I know I'm sitting here kind of thinking out loud, and you see Venki going, thinking enumerate, and you're like, what is he talking about? So, what is Venki talking about? So, let's look at this. enumerate object. We wanted, we want should be AB. Yep. Iterable column title, and let's list this. One place, two place. One place, two place, three place. Because I'm thinking even, can we reverse it? Because I can already, so like this one right here, because we need to take, so if this was, let's just say it was ZZY, what in the world would that be? So I'm barely keeping up with this. So would it be would it be 26 squared? So this is where the problem with my math is weak. Let's run this. Column title ZA. And since it's len of 2, we could do it in reverse. And then do the len. All right, so this is what, because we need to know what to multiply by, because we don't think about it, but our brain is actually looking at this way. And we're counting it, but we're literally going, that's a tens place, or that's a singles, that's a ones place, that's a tens place, that's a hundreds place. Because we have to know how many are there. Because you're not actually going, oh, that's 3. So here's the trick about how our brain understands. So that's why I'm kind of intrigued by this. Our brains do a lot for us that we ignore. So we see that, so like, here's an example. We know that's a 3-digit number and that's hundreds. But we know it. We don't know it here. We don't know it here. We know it by here, but we say this is 100. But we're actually, our brains are counting this way. Our eyes look at this. And even though we read left to right, or in English we do, there's, and I commend everyone here, and I know I have quite a few individuals who come in and they say, my English isn't good. Don't worry, my English isn't good either. So I speak 0.8 of a language. If you can speak 2 languages, you're better than I. So all right, but we look at this and we go, that's 100 because it has 3 digits, but we're actually looking at it from this way. We don't know it's 100 by looking at, because let's say we blank that out. So we need to count and look at this in reverse. So I'm wondering if we take column and then we do this, ZY, and then we find out the length of ZY. 2. So we know to take this one, pull it, And if it's a length of 2, we're going to multiply 26 by this. Now, what would it be? Is everybody following me on that? Now, Venki solution, do not hold me to this. This is, I get stuff to work and then try to optimize it later. Venki has a very outstanding skill to be able to write optimized the first try. I don't say that I can do that. So, Venki, how is it going with the enumerate issue? This is where I'm landing right now. I'm going to take it, I'm going to flip it. And so if I iterate through here, so the first time through, I multiply. So what would it be? What would it be if it was Z1? What would happen? Let me pull up Excel. What would be after ZZ? Would it be ZZA? I don't know. Do I have Excel somewhere? What comes after? What column comes after ZZ in Excel? Excel has 16,000. Do I have an Excel sheet somewhere? Wait a minute, I think I do. Let's see. Let's bring this over here. Woo! Alright. This is going to take a second, because I want to design this. I'm on M O P V W. Okay, there's. Oh, I'm on Y. Hang on. Z Y. Okay, Z Y. Z Z. Then it would go A. Okay. A. So what would be A? Because if we can do this, and then I would iterate and do an index on this. All right, Venki, using fingers on one. I love it. I want to can count up to 31. Okay, I like that. Okay, so ZZYAA, I am stuck converting into its corresponding values. What part? Here? Because I got this. I'm concerned about a 3. Because I already know where Leetcode is going to go. Oh, and hey, everyone, do me a favor. Click the like button for me if you have not already. I appreciate it. We have our core audience, and I really need y'all's help. So if you guys are appreciating these videos, I greatly appreciate that. All right. So I'm liking this so far. And then we will index over this. So I would take my Y, I'd pull it up, And then since this is the second one, so we're going to do something like this. For I in range, range, we're going to go backwards. Do we want to go backwards? Would that solve our problem? So we don't have to... Vinky, if we just index through this backwards, would that do it? For I, and then we don't have to flip it around, because this is going to screw with me if we start to flip things around. Vinky, range, sorry. Len, column, title, to 0 minus 1, print I. All right, so let me walk you through what's in my brain right now. So if it's 2, we need to do something where then we're going to, let me do this, put this over here, print I, F9, run this. So if it's the 2 position, we're going to if it's the 3 position, we got to do something else. There's got to be math. So when it's a second, is this it? Okay. Yeah, that's not it. So what did I... Okay. It's not to the power. That's the place. So it's the place, it's to the power. Wait a second. All right. So the place is to the power. So the first... If it's a 1 digit, it's here. If it's the 2 digit, it's here. If it's the 3 digit, so we just convert this. So that's 3 numbers. Then we need to convert this 26 times 2. It's 26 times 26. So our base. So basically if we, here. It's like if we had a key, so that would actually be 0. It'd be more like this. There. I love these easy Leetcode challenges. It makes me feel very unsatisfactory in being able to. You're done? Fantastic. If anybody's interested, go throw it over on the Discord server. Don't paste it in here. But that's awesome that you're already done. Nico, are the spots showing up yet? Because the sun just came out with a vengeance. Okay, and the time change is about to happen here. All right. Yeah, I don't want to see it yet. It's probably, have you run it through Leetcode to test everything? Here, I will give you, here, go and try it and run it through here and see how you fare. See if you handle all the issues. So if it is 2, but I gotta handle the, I don't want to do an if. I want to handle. So if it's a second place, because human brain is going, oh, that's Z, so that means it's 26. 26 times, so what would I want to do this for a second to see if I can make this hurdle. So AAA, what would AAA be? So that's 701, 702, 703. So that would be 26 26. How would I get, what did I say, 703? 703. So what is the, how is, so it's 26 times who? Even though I was just here where I saw this and I was like, hey, that's 26 plus 26 times 26 plus whatever y is, 25. All right, so what is AAAA? I got 3 A's. So I've gone through this 26. Whoo. Dema, did you, if you put in triple A's, will you get 703? 26 times, so then we roll it over one more time. So then no, 26 times 26 times 26. Let me check my math on the Excel. So ZY is 701, 702, 703. I'm hoping that if I derive this, this will make the math. Dema, were you able to, was your solution, does it work in that Leetcode problem? So what is the math on this? 26 times 26 times 26? No. So then I have, so then I roll it over. 26. So Z and Z is 26 times 26 plus 26. So this is the equivalent. No, I want this. There we go. That is the equivalent since it's pushed over. Six times 3. Nope. 26 times 26 plus 26. I don't like that. I don't feel like that's a good solution. And then I were to take this and then plus 1. Because I know this is 26. 26. Alright. So this is just my key. This is 1 times 26 plus here. This is 26 times this key. All right, hang on. Plus this. Oh, I thought I had it. Oh, I thought I almost had it. But Dema, was your solution? Did it run in Leetcode? Because I'm curious. I may need. May need a nudge. How long have we been on? 53 minutes. I may take a pause here and record a video and let this kind of percolate. I don't know why I can go from here and can't make this leap. Key value. 1's already been through here, so it's 26. And it's been through here 26 times. So now this is 26. Okay. Wait a second. $26. I thought I had it. Let's get it to work here. And we'll worry about this later. All right. I know it's going to happen, but we just need to, because I know we're going to get like a ZZZ. ZZZ. Yeah, that's 3 Z's. I have no idea what that'd be. I'd have to scroll all the way through, and we'd be sick because it's going to become exponential because the base of this. So one more. So that could be. Wait a second. Not coding, just watching for now. Okay. Got it. Oh, I thought you said when you were done for the done for the algo. I thought you had solved it. Okay. No worries. Because I am, like I said, I'm stuck. I can't even get my human brain to wrap around here to find this algorithm. This is simple to me. This I'm not getting. It's going to be close to this, but that feels very hard codey. hard coding. I know that's a weird term. I'm cheating. I'm putting in. I'm getting it to work. But like this right here, this place, whatever this place is, this key times 26 because I've already been all the way around. But and then you're adding. So adding, multiplying. Okay, hang on. Let's see if we can get this. Ones place. Well, what's the rule for? Let's go back to the rule for a base 10. Oh no, I was behind a few minutes. Sorry, I was responding when you asked to like the stream. Oh, thank you very much. No worries. No worries at all. We are a very, very happy group here. Thank you for coming to hang out with us today. I'm trying. So Dema, I don't know if how long have you been here or around. So kind of the live streams are kind of two-prong. I'm applying for jobs, and I'm realizing that I need to be applying for data engineering jobs because that's what I guess what I want to do, and kind of inadvertently what I had been doing. So I'm trying to stay fresh. So when I get an interview, and more than likely I'm going to get a technical interview because that job is going to be extremely technical, I'm trying to keep my mind sharp because I realized that I wasn't doing any problem solving. Because when I got my last job, I realized I wasn't doing any. I wasn't recording anything because I didn't need to keep my mind. I didn't need to do any problem solving. That's all I was doing all day. It's not that I wasn't interested. The YouTube channel was created to push me and grow me as a developer, and Venki has knocked it out of the park. Boom. That's it. Venki's got it. So as we go through, there's the math. Love it. So how would we... That's the math. Now we got to turn this into... So if you're just looking... Let me see. Can you copy? Can you copy from... All right. I 100% agree with this. Now the problem that I have... So this needs to be recursion too. I'm awful at recursion. So this is a recursion problem because we're going to need to take this. So we don't even need to do a for loop in here. Okay, all right. Maybe this will force me to practice my recursion. So we won't need to do anything like this. So if this is... So if it's a 2-digit number, it's this and this. So I knew Venki was going to get a solution before me. Venki is very good. All right, so help everyone out with what Venki's solve is. So let's look at ZY. All right. So this is the key times here through here. So let's comment this out. Now let's replace this num. We're gonna replace this with key D DZ. We're gonna try this, but I believe Venki is 100% correct. And then replace this with DZY. And Y. This is what you had in mind, Vinky, correct? Comment this out. Vinky needs to start doing these live streams. What was 28? I trust Vinky's math. Because this should be 26 times... Oh. Excuse me, everyone. Yep. That was my fault. Num. Bingo. So now we need to turn this into conversion. %. So let's go through what this is doing. This is 100% awesome math here. Now, I can kind of see the recursion. I can do this. I want to do this in a recursive way, because that's going to be much cleaner. And Vinky, we're going to set up your YouTube channel, and you're going to start live streaming and solving these, because I think this is like the 5th or the 6th one that you've have a much cleaner. So if we were to do this, plus, because it's plus, right? Yeah. So len, and let me try to get this out. So as the number of place is, we're going to start with basically that -1. So if it was 2, so let's go through the math here. If you're not quite following Vinky's very elegant solution. So when you take a number, you multiply it. So 26 raised to the power of 0 is 1. So we need to tweak and being off by 1 in Python is super easy. We can just adjust it over or utilize our indexing. So if we were to go through this backwards, and this is our first starting point, that's also 0. So list, range, len, column, title, one more. There we go. 0 and 1. Ta-da, 0. Or what is going to be a more elegant solution is if we start here and the length is 2, but we automatically just go like 2 len blah blah blah, it's going to be 2, then we come here -1. Let's see, place column count. I don't want to do column count. Number, column number. There we go. I can do that. Column. Even though I deal with columns all the time, or I used to, I still hate typing column. I can't spell column, and my fingers do not want to type column. So all right, column's going to be the X. Oh, I love it. I'm so envious of Vinky's math. This is so beautiful. This is what I was trying to solve. So then if we were to do, here we go. Let's comment this out. And we were to change all these. Let's not get rid of this because that's so pretty. So then if we were to do, let's change this to A. Was that A? Yep. A. And then nothing changes here. Nothing changes. And then this goes to 2. This goes to A. Let's do pass. This doesn't. I'm surprised this hasn't thrown up yet. Oh, I don't even need this. I can just run this, right? F9. Num 703. Boom! Venki is all over it. I love it. Yes. So, all right, let's go over the math of this. So, if it's a single digit, it's 10 to the power of 0. Power of 0. 1. So, our key, so if we have, and then this is base 10. Oh, I love it. I love it. I love it. I love it. Venki has helped me with a lot of my gaps in math. And here we go. So now, Venki, you're going to need to help me with the recursion here. But we also know that Leetcode doesn't like recursion, right? Let's do it without recursion, and then we can see where we are. Because I'm not going to be able to do the recursion anyway on my first with you all, but I would need to. That's probably one thing I need to practice. Let's do this. Oh my word, recursion. I don't even think that might be recursion. All right, so here we are. So for I in len, yeah, it's going to show runtime error for recursion. Why does it do that? I mean, that would be because we did that with your solution of the stair step, right? That was 100% Fibonacci. Perfect recursion problem. So for those of you who don't know what recursion is, I'll pull up a factorial solution here in a minute, and it's just so elegant where it's the only time where you can call the function in itself, and it goes down until it reaches a limit that you've set. So let's get this done without recursion, get it to run in Leetcode, and then we will do this. But oh, Venki, I'm ecstatic of this solution because this is base 26, I believe. And then you're going through. Oh, so elegant, so perfect. So all right. So we're gonna go len x. Let's say yes, climbing stairs. Because it was recursive and all right, it was recursive and Fibonacci, which Fibonacci is recursion. All Fibonacci are recursion, but not all recursion is Fibonacci. All right, and it is very interesting how in nature Fibonacci numbers are everywhere. And if you don't know what a Fibonacci number is, it's you take a number, you take its previous number, and add it together. So 1 and 2, so 2, its previous number was 1, is 3. So then you have 3, its previous number was 2, that's 5. 5, its previous number was 3, that's 8. 8, 5, 13, 13, 8, so on, so on, so on. 13, 8, 21, 23. I can't remember. But all right. I'm drowning and everybody else is leaving. So let's get this done. We had 36 individuals come today. So, all right. So we're going to loop through here. I guess technically, yes, we do need to go backwards because we're going to be iterating through forward. All right. So len x range. Okay. Range, let's get this right. X minus 1 oh, let me get this changed up because we're going to paste this in and it's going to throw up all over the place. Yeah. Print I. Column num. Num zy. 0 and 1. All right. So this needs to be +1 outside of this, +1 0 and 2. So I need this in reverse. 0 0 0 0. I need 1 to come out first. -1, -1. So what I'm doing right now is I'm just getting the index to work. -1. So what I'm doing is I need, all right, so I'm getting the power in the order here, the order of this. So if you're just joining us, don't want you to think that I'm smart enough to come up with this base solution here. Venki has come up with this algorithm of devising. We're looking at a Leetcode challenge problem of converting these column numbers in Excel to what column number it would be. So this is, of course, 1. This is 28. This is the 28th column. This is the 701st column. So these were mentally easy for me to do. I had to go and count this, but I could not derive the algorithm. I could do this, but I was doing this the long-handed way, where it was, and Venki goes, hey, got it. Boom. So here we are. So we need to, if we pass in z and y, we need to get this right here. Total. We're going to get num equals 0, not minus, 0 right here. So then each time through, we're going to take whatever the index, shoot. Okay, that's the power. Ooh, Venki, you see the issue we're going to have? We need to index through, but here are the powers. So oh, I see what you were talking about, enumerate. Okay, all right, let me get this out of my head. So 1, we need to index through, and 2, we need to power. So what am I talking about power-wise? All right, so this is index 0, but this is going to be power 1. This is going to be index 1. This is going to be power 0. So do you see how we need to go through this Okay. All right. Now, Venky's probably already has a solution for that as well. So we need to iterate through. Is that what you were thinking about? Enumerate? I may be out of. Am I slouching? So between me slouching and me getting comfortable and my chair, I was probably all like this and down and out of range. Down and out of range. Wow. Down and settled. Sorry. I was getting some Telegram messages. Let's see. Whoa. What? Sorry, I have looking to see. Sorry, I'm trying to always navigate between real messages on LinkedIn and garbage messages on LinkedIn. And same thing with email. Some of them look really, really real. Some of them look really awesome. And then you're like, wait a minute, I don't know this person. So sorry. I was getting excited there for a second. All right. Venky probably already has this solved. And it's like, you're not thinking about this right. So one way through, we need to, Venky, if we flip it, like I was thinking, that would solve it, right? So then we wouldn't have to do it twice. That feels so slimy. I mean, it's going to work. So if I were to go through here, because our brains are doing, this is why I'm obsessed with this. And I know I drone on about it. But I promise, our brain is doing so much more and filling in so many gaps. Do you know that when we see things, we don't actually see all of them? Same thing with like a television. I think the television hacks our brain and our eyes fill in the rest of the colors. But a perfect example of like illusionists, they exploit those gaps in our brain. Here's my favorite illusionist story of what our brains see and what we're programmed to see. There was this light that they cast down on a stage, and they had people on both sides of the stage, and they said, count how many people come in and out of the light. And I was like, I can do this. So that's where they set that piece right there, where your brain goes, I'm going to be looking at the light and I'm going to be counting the people. That's all I'm going to be doing. And that's all it takes right there. So do I have light coming in right now? Yes, I do. All right. And we may pause here and me try to do a video so I can have good quality here in a minute. So, all right. So as the video, as it goes on and then it's counting for like 30 seconds, like, okay, how many people saw the bear walk on stage? They didn't even ask you the question because what they gave you was a distraction. And I'm like, a bear, I bet it ran across on stage and it was barely there, blah, blah, blah. No. This was an oversized mascot bear that walked slowly, paused at the center of the stage, looks at the camera, and continues on. But our brains are programmed to see what we want them to see. And that's also like if you play an audio of one word being said and the video of their lips saying another word, you can't hear it because your brain is reading the lips and filling in the gaps and going and trying to figure it out and scrambling your auditory nerves, and you hear and you just hear muffled speak, and then they put the right one with it and you can hear it. All right. Okay. Those pixels are made about frames per second. Yes, I worked on the math so far, taking base. So I worked on the math so far, taking the base equals column title 0. Ooh. All right. So is it dynamic enough to handle if it was 5 characters of A? So, all right. Actually, I want to pause here. Let me try to do a video of over-engineering before this light goes, and then we'll come and finish this. So give me 1 second, everybody. Let me give... Was that the solution? Because I want to point out, I want to talk about, see how bad are the teeth. That's so bad. Ooh. All right, I know what I'm going to talk about. All right. Okay. All right, and bad. All right, I just won't smile super big. Over-engineering. Hi, everybody. This is Sam with Python Basics. So I want to talk about a subject that is near and dear to my heart and something that I have to guard against every single time. So over-engineering, you might go, what in the world are you talking about? All right. So once you move past beginner level and intermediary level and you're really starting to progress. So what happens is it's a variation of human nature where you already begin to assume things and you go, oh, I know what this is, and I need to protect against this, and I need to guard against this, and I need to. So if you feel yourself using the words I need to or I know what this is, stop. You're already on the path of over-engineering something. So you need to be very, very careful, because over-engineering, in my experience, is you're trying to solve 5% of the problems. You're outliers. So what I want to challenge you with is get it to work 95% of the time, build it, get it working, then go and focus on those outliers, those edge cases, those 5%. Because you can go down this rabbit hole and you end up making this overly complicated thing, this monstrosity, and then it doesn't work at all. It's non-efficient. It's not even doing what you wanted to do. And then you're going to need to start back over. So write a line of code, test it, fix it, get it to work. Looks like I'm going to need to use the gray piece. So if you feel yourself already knowing how to solve the problem, already truly thinking you already have the problem, that's where the ego comes and lies and tells you and goes, oh, I know what this is. Well, you just saw the problem. You don't know what it is. And you see it in industry from throughout all industry of assuming that we know where the mistake is, assuming that we root cause analysis. We've never really talked about that, but making sure you understand what is really the problem. What are you really trying to fix? And where is the root? Drive down to the root. If you really want to engineer a solution, drive down to the root, find out how it works, what it is and how to solve it. So, real quick video today. Please make sure you're hitting that like button. Please make sure you're hitting the like button, subscribe, notification bell. Make sure you're jumping over to the Discord server. We're having a lot of great conversations over there. So wanted to make sure that you have the support that you need and want. But as always, everyone, thank you so much for watching, and we'll see you next time. Bye. I need to start doing those first. I don't know. How was that? How's the color right now, everyone? Okay, I'll edit that after we get done, and I'll record 2 more tomorrow. Well, remind me we need to do that first, everyone. Vink here, Nico. All right, so let's get back to here. So if we flip this and go in reverse, we would have the power, and we don't need to... This feels yucky. Feels very, very yucky. Okay, that's the same one. Does everyone know how to reverse a string? So then... Hang on, I want to make sure this isn't a garbage text and I'm not missing anything. Nope, just commercial. Thank you, everyone, for hitting that like button today. I really appreciate it. All right. So now we're going to take, let's call this power. So is power a keyword? It's acting like, let's do exponent, EX. Because power looked like it was wanting to... No, it's, okay, X is a variable. Cool. All right. So now... No. I still don't know how I get that to open. All right. 1. So print num. So then now I'm going to take my key. Oh, it's... So I is going to be yuck. I is also going to be, oh man. All right, num plus equals times 26 to the power of I. All right, let's try this. 1, 2, 3, 4, 5. What doesn't this like? Key value I line column number. What is this? 5 and column number doesn't like. Oh, this is index. This is index of, that's right. I'll go through this in a second. Let me get this out of my brain. I know I'm doing a lot of unpacking here, and I'll go over this. Okay, so what did I just do? So I solved 2 problems. So we need to know how long this is. So we need to assign this to our math algorithm, that if it is this place, it's this to the power of 1. If If it's the tens place, it's 26 to the power of 0. And we need to have this because we're going to be iterating through. So I'm doing this in reverse, and I cheated. I feel like I'm cheating right here. So I flipped this around. So I did this in reverse because if we didn't do this in reverse, we would need to iterate through one way while applying the opposite of the power, because this is index z is index 0 but with a power of 1. Y is index 1 with a power of 0. But if we flip it around, they correspond exactly. So when we flip it backwards, then Y is index 0 and the power of 0. Z is index 1 with the power of 1. So we flip this around. So then now I have that's that algorithm right here. But then I'm needing to slice index out. Hang on. The column. I hate that. Right here. That should not. Oh, I'm doing it here. So now let's check it against column. And let's make sure I'm honoring Venki's math. What? Sam? Oh, good Lord. AAA. AAA. Let's run these two. Bingo. All right. So now we need to return and then we're going to try to see if we can do this with recursion, because I know I've got to improve my recursiveness. All right, let's get over here and try this solution. Does everybody follow how I did that? Took Venki's math algorithm and turned it into Venki. Did you get it? Let me see. I think Venki was talking about it does not like. What is this not like? Column title 1. Did I column title 1 num doesn't like column title I for I in range negative. Yeah. I'm getting a weird error. D. Oh. I missed all of this. Let me put all this in here. All right. Yeah, it's like, hey, we don't know what. Let's see. A, B. All right, let's run this. See how we have it. Woohoo! All right, this is all Venki. Venki, have you run it inside to see? We don't like doing that because it makes everything look yucky. It's too much white. It's awful on memory, but look at runtime speed. I think that fits. Let me get closer. As yellowy as yellow can be. Right, 26 milliseconds, and it's on this side because this is all Venki's math right here. But we're losing a lot. Seriously, losing a lot on memory. We're not. Oh, because of this. Wonder how. Still seems like a pretty good solution. Venky, did you? Dax, morning. What did you miss? What did I miss? I guess I don't like this is taking up a ton of memory. Oh, when I first ran it, I didn't have this in here, but I guess it's saying, I guess I'm having to import this string, so it's module. Oh, okay. How about we clean this up? So, all right, here's a way to improve memory. So I'm bringing in this whole module. Let me see if this from string import as key upper. Let's see if this as upper. Let me see if this speeds it up. All right, and we'll go over what I just did right there. No. See if that speeds up memory just a little bit. Guess it doesn't like that I'm making. Nope. kept it basically the same. Really? I wonder if I. Well, now I want to see if I can make it better on memory. Now it's even slower. I'm down at 51, but I'm going to take credit for being at 96. All right, so Dax, you'll appreciate this. So it is, this problem is taking and finding out what number column you'd be on if you were in Excel, and basically if you got down to column ZY, what column number would it be? And it's the 701st column. And I'm pretty sure you've had a couple of these. I've never been out to 701, but I have been into the 8 HKs before, I think. And so I was able to kind of visualize this, but I could not do if we had an issue here and we got to AAA. But Venky, being the genius that Venky is, was able to derive this math algorithm of the places. So I was trying to visualize it with the base 10, but I was unsuccessful because 10's place, 100's place, and then you go on from there. So if that was AAA, bingo right here. And num 703 AAA. So what we did is elegant / garbage solution. That what we did is, I know there's a recursion solution to this, and I'm not good with recursion, but I also know that I need to improve with recursion. But I can loop through pretty much anything. So what we did is we took a range function and we got this to come out, and you can go back and you can kind of see. So we got this to work out, that would be the power of 1 right here, and that'd be the power of 0. But as you iterate through, this is 0 index, that's the first index. So we're going to have a problem where at first I was like, we're going to need to have two ways to go through this. And then I was like, well, wait a second, or we could cheat and just flip this around and go backwards. And basically, because I think our brains actually look at this backwards. Because I think we actually look at this and we count here. So we actually look at this in reverse. It's not like, hey, this is a single digit. Okay, no, it's 2 digits. No, it's 3 digits. And then we go, well, if that's 3 digits, then this isn't the hundreds place. This is the single place. So I actually argue that our brains look at this in reverse. So that's why I feel a little bit more comfortable flipping this around. So as we go through this, we get a 0 and we get an index and a power at the exact same place. And this first time through is 0, and we take the single place, multiply that by, we zero out 26, which any number, 26 to the power of 0, we get 1, ones place. Then 2 place, so it's already all the way through, and then 3 place. So there we go, and we actually got a pretty good score. Let me run it one more time and see what this solution is. I'm taking credit. Whoa. Now it just ran and it said it was 45 milliseconds. I'm going to take credit and say on the first run, it took 26 milliseconds and we got down here. So, all right. We just recorded also a video for today. It'll publish sometime in the afternoon or evening for most of you. It will be, I'll probably publish it at noon my time. All right. Let's see how long have we been here? And we got the light peeking through. If I were to just put this is how lazy I am. If I were to just put drapes up over here, it would solve all this lighting problem. And if I just take a sheet, I think it would drive my wife nuts if she saw a sheet hanging on this window here. My son says, we theorize that if I move over to the other desk, my old work desk, that the lighting would be okay. But it's sideways lighting, where here I do get I get a lot of backlight. All right. Let's see. Rambling a little bit. I guess an hour and 44 minutes. That's pretty long time. We usually cut out at 2. Try not to go over 2. I think the other day we did 2 hours and 20 minutes. Of course, I couldn't solve that. I guess we could try to do recursion here for a minute. So if you don't understand what recursion is, let me see if I can find factorial. Factorial. Here we go. Bring this over here. This is the only time you can, it has to be a recursive problem to be able to call itself. So we will look at this. So does everybody know what factorial is? It's the number multiplied by its preceding number. So if we're going to do 4, it's going to be 4 times 3 times 2 times 1. All right, 24. Run this, 24. So take in x. So here we are. And see how this returns 1? So when you get down to 1, it stops. That took me forever to understand. So when you get down to 1, it knows, okay, I need to then return, boom, stop. Because else come down here. So it's basically, let's try to visualize this. So this, when you call this, that goes here, then you're going to multiply it by x minus, so it's in parentheses, right? So x, let's make x 4 so we have the same. X times parentheses x minus 1, right? Okay, so that's 3. So is that 1 yet? Nope. Come down here. So then now x is 3, right? So then, so that's 4. So then we do it again. So now it's x. This is where it gets weird, where I see it in my head. I saw this done out, and I should have done this in done this with 3. So it would be the equivalent of then x. So then you lump this back in. It would, what was it? This is why I'm so bad at factorial. So then be x minus 1 minus 1. If I recall. There we go. Because then now this is 1. That's what this looks like. And I know this looks weird, but you're first, and then you actually do this then one more time, but this is 1. So let's do that one more time. Let me see if I can do this right. Times this minus 1 wrapped around here. Bingo. And this should be 24 still, because this is 1. This is what recursion is. And if you think about it, this is the exact same thing. So I'm doing a loop here without doing a loop, right? Because I'm coming back through and I'm calling itself, and I'm calling itself until it gets to 1. And this last one, of course, is then 1, because I get to here. And that is in and of itself. So now let's see. Hour 49, it's almost 25 after. Let's see if we can do this in recursion. I'm very nervous, but this is what I got to do when I get an interview. I'm going to have to do things that terrify me. All right, hang on. Let's see. Okay, actually, I may need to wrap up. I'm going to, we can practice this. I'll practice this tonight, and I will see you all tomorrow, and we'll probably record at least one more video, hopefully 2. But bye, everyone. I hope everyone has a great day. Thank you for coming, hanging out, and I will see everyone next time. Bye.